Hi students, today we're continuing to learn about Standard 3-1, which talks about uneven distributions of Earth's mineral energy and groundwater resources as a result of past and current geosciences processes. Remember, we're focusing on the word energy today, and so we are on LT5, which talks about alternative energy such as solar, wind, and water. Today we're focusing only on wind and water. Let's get started. So this chart, you have already seen it. I just want to remind you that around 80% of the United States' energy comes from coal, petroleum, natural gas, which are the fossil fuels. Only 9% of the energy today comes from renewable energy or energy from renewable sources, such as wood, hydropower, biofuels, solar, wind, or geothermal. If you compare it to the rest of the world uses more renewable energy. About 19% is renewable, and again, most of it is still fossil fuels. Let's start with learning about where we get our energy from. So energy is created in power plants, and then it gets transmitted through power lines, and then it goes to the rest of our community. Let's zoom into the power plant, which is here. Inside a power plant, we have turbines and generators. So let's talk about how these two parts of the power plant make energy, because this is kind of the heart and soul of making electricity here. First, we have the turbine. A turbine looks like this. It's actually a machine that produces what we call mechanical energy or energy of movement. It has a moving part called a rotor assembly with blades attached to it. Now, water, wind, steam, gas from burning fossil fuels can move these blades and rotate it very fast. And as the blades move in a circle, that creates mechanical energy. Now, this turbine is connected to what we call a generator. This is a picture of a generator, and the turbine is attached here. There's a rod that spins the inside of a generator, which is a set of wires, very quickly, and there's magnets surrounding the wires. And what happens is when the wire spins through the magnetic field very quickly because of the turbine, it creates an electric current which runs down and goes through to the transmission line. So the spinning movement with the magnetic field is what creates electrical energy. And then from there, it gets transmitted from wires to buildings and homes. Now let's talk about what a coal power plant looks like. So I wanted to show you these pictures because most power plants pretty much operate in a same way. The only part that changes is what it uses for moving the turbine. So in a coal power plant, you have coal that's being burned. It heats up water, which boils and creates steam. The steam is what spins this turbine really quickly, and as it turns, it generates electricity from the generator. If you look at a petroleum and natural gas power plant, it's pretty much the same thing, except you burn petroleum or natural gas to create the steam. It spins the turbine here, which creates electricity in the generator, and then the electricity moves to the transformer and to the transmission lines. Finally, if you look at a nuclear power plant, it's pretty much the same thing. I haven't really talked about nuclear power too much, but in nuclear power plants, basically, you are splitting an atom in half, and when you do that, it causes a humongous explosion. That explosion causes water to boil and create steam, turns a turbine, goes to a generator, which creates electricity, and it goes to the transmission lines and to our homes. So I just wanted to point out that all the power plants have the turbine and generator. See? It's kind of the heart and soul of a power plant. So now let's talk about alternative energy, which is the idea of using renewable resources to generate energy. So these are some examples of renewable energy sources. So wind, water, geothermal, biomass, solar. Let's talk about hydroelectric power. So basically what that is, it's electricity that's produced from the movement of water. So you can see here, this is a dam, and dams actually build up a lot of water pressure because it's holding up the water here, and then it lets it out in small increments. So as the water shoots out, that actually has a lot of energy. So when you harness that energy from a dam, so when the water shoots out, what it does, it spins a turbine that's down here. That spinning movement will generate electricity in the generator, and that electricity will travel to the power lines. Um, and most of the major streams and rivers in the United States are already converted into dams like this to generate electricity. This is a map that shows where hydroelectric power is used in the United States. As you can see, most of the coastal cities over here on the West Coast and the East Coast have a lot of hydroelectric dams and hydroelectric power plants. Overall, though, it only accounts for 3.15% of the total energy in the United States, which is a very small amount. If you look at the world, similarly, only 3.8% of the world's total energy is made by hydroelectric power. Some of the leaders in the whole world in hydroelectric involves Canada, Brazil, and China. Now let's talk about the advantages. Well, first of all, it's renewable, so you can always have water to make this type of energy, which is good. We're not going to run out. It's flexible. That means that you can generate energy whenever you need. So, for example, let's say during the evening hours when everybody uses electricity, you can actually pump the water up the dam again and make it flow back to generate even more electricity if you need more. Some hydroelectric plants collect rainwater to protect against droughts. It causes less pollution and very low maintenance costs, so 4 cents per kilowatt hour, so it's fairly low on the expenses. And it creates a fair amount of energy, 96,000 megawatts per year. Pretty good. Some of the disadvantages of using hydroelectricity is that there's a limited number of places to build dams. So there's only so many rivers and streams you can build dams for, right? Second, very high cost to build, very expensive. Dams can damage ecosystems by flooding them and killing the plants and animals. Turbines can change the current in streams and affect fish. And this is just a picture from a website that talked about how turbines and dams have been affecting fish. And dams make it more likely for cities near deltas to flood. So this is just a picture of a flooding near a dam. And that's because dams hold up a lot of water, and when it rains, it causes more floods. Now let's move on to wind power. So wind power is electricity that's generated by the movement of wind. And this is a wind farm. Basically, it's a bunch of windmills. Let's talk about how it works. So let's first talk about what wind is. So wind is formed when the sun heats different locations of the earth unevenly. And as some air gets heated, the air moves from hot areas to cooler areas. And when that happens, it produces wind. This wind can be used to turn a turbine that's in here, which is connected to a generator. And the generator creates electricity, which runs to the transformer and to the power lines. This is a world map that shows which countries actually use wind power the most. And you can see the United States, some of Europe, China, and India are actually the leaders in wind energy. However, out of all the total energy in the world, it only accounts for 0.39%. So that's a very, very small number. We'll talk about why the number is pretty small in a minute. This is a map of the United States where wind power is most commonly used, and you can see the center of the United States is where the wind power is most common. Not so much in the coast. We have some in California, not a lot compared to the central states. And it only accounts for 1.17% of total energy in the United States. Very little. Well, let's first talk about the advantages of using wind energy. First of all, it's renewable, so it can be used over and over again. It does not release any pollution, which is good. Wind turbines are really efficient and capture about 85% of the wind's energy. And last but not least, 1 megawatt produced by windmills can power 200 to 300 homes per year. So it can power quite a few number of homes, each one. Now let's talk about the disadvantages. So first of all, This is the most significant disadvantage. Only certain areas of the world get enough steady wind to produce electricity. So take a look at this map. This map kind of shows you where the strongest winds in the United States occur, and you can see it's mostly in the central states. So, and if you remember the map that I showed you here, I told you most of the wind mills are in the center, and that's because most of the wind occurs there, and not so much in the south or some places near the desert down here. Second, it's noisy and it could also be dangerous to birds. Some people find it very unattractive, so they don't want to install a big windmill in their backyard. And finally, windmills are expensive and they can also wear out very easily. So that's one last disadvantage. So that's it for today. We are only talking about wind and water today. Next time we meet, we're going to talk about other alternative sources of energy such as solar and geothermal and biomass.